Hello everyone, welcome back to the CCNA training. I hope you guys are doing well and we'll start in a minute. Let's wait for a few more minutes. Some people are still joining. So in the last class, we discussed about access control lists, and majorly there are two categories. The first one we have is standard ACL and we have extended ACL. Standard ACL ranges from 0 to 99. Then after that, we have extended one from 100 to 199. Standard ones are applied nearest to the destination router. And these are applied nearest to the source router. In the last class, we did a practical lab for standard ACL and extended ACL as well. But since some of you had doubt in extended one, we will again do a similar lab for the extended ACL. And after that, we will look into NAT, which stands for Network Address Translation. Let's quickly move to the packet tracer and create a topology similar to what we did yesterday and try understanding extended ACL more accurately. So let me get my packet tracer for you. So we have the topology here, and now we will quickly connect them using the cable. And this will look like okay. Let me quickly add a module on the router. So basically, we are going to configure a network of 1.0 on these devices and 2.0 on these devices, 3.0 on these devices. In these two routers, we can configure 4.0. So let me quickly write the objective as well. So the main requirement of this lab is that only devices from 192.168.1.0 network be able to configure router 0 remotely. Make sense? So this is our objective for today's lab, and we want only these devices to be able to make or create telnet sessions for configuring router 0. So for that, we will be using extended ACL, and let's begin the IP configuration first, and after that we'll move ahead with creating ACL. So enable conft interface FA00 IP address 192.168.1.1 interface FA0/1 IP address 192.168.2.1 and the subnet mask, then no shutdown. Now the last interface Ethernet 1/0 IP will be 192.168.4.1. I'm also creating the DHCP pool for the end devices. So IP DHCP pool A network 192.168.1.0 192.168.1.1, and you can rename this as R1. Now we'll move to, okay, so we have to create another DHCP pool for 2.0, and we can create a DHCP pool with a different name for network 192.168.2.0. Now we'll see if PCs are getting IP address using DHCP or not. So DHCP is working fine. And here we go. We have the IP on all of the devices for network 1.0 and 2.0. Now let's quickly configure router number 2 as well. So we will go to CLI, say no, enable conft change the name to R2. FE00 will be configured with IP address 192.168.4.2 and no shutdown. FE0/1 IP address 192.168.3.1 and no shutdown. Here we are done with the IP configuration, and we have successfully created the DHCP pool as well. Now let's give IP to the PCs and move ahead with creating ACL. So the DHCP gets failed here. Let's try it again. Okay, it works now. Now, in order to make communication between these and these devices, you have to configure routing as well. So we'll quickly configure rep on these devices. And advertise our directly connected routes, which are 192.168.1.0 2.0 and 4.0. Go to router number 2 and configure the RIP. .0. Take an exit. Now let's try making communication between these devices. Okay. So it goes successful and PCs are able to communicate with each other. Makes sense? We have successfully configured RIP and now we are going to configure telnet on router number 0 so that the PCs connected can configure the router remotely. So we'll go to conft and set a enable password first of all. So we are using Cisco as our password for enabling the router. Then after that, run the command line vty 0 space 4 or as much as you want. So these are for creating virtual lines which can be used at the same point of time to configure the router remotely. So press enter. Then after that, create a password for getting logged into these virtual lines. And password will be, let's take Cisco again, then say login, take an exit. Okay. That's all. So let's try creating some remote sessions using the command prompt. And if we say telnet 192.168.4.1, it asks you for the login password. We used Cisco. We'll type Cisco, press enter, and now you are into the the user mode of the router. If you say enable, type the enabling password, you are into the enable mode, and now you can make configurations by entering the configuration mode. So that's how you can remotely access the router using the PC. Now, if we try making telnet connections even from these devices which are there in 3.0 network, we'll be able to do that, right? So if you try doing telnet using a device from 3.0, that's also working, and you'll be able to make configurations using the PC from that network as well. But as our requirement says, we want only 1.0 PCs to be able to do that, right? We don't want PCs from network 2.0 or 3.0 to create telnet sessions. For this, to make this requirement meet, we will use extended access control list. Okay, so I hope you guys are able to hear me, right? Someone is saying that class is cancelled. So can someone please inform others that we are live and he can join? Okay, so now we'll be creating ACL in order to control the telnet connections from PCs. So we'll go to router 0. We are going to create an extended ACL, right? So we'll be using the source router, the router which is nearest to the source. So we'll be using router 0 to create ACL. So let's run the command access list and 0. Then permit, because telnet is a protocol which uses TCP. So TCP. Now if you press question mark, it asks you for the source address. So the source shall be network 192.168.1.0, 192.168.1.0, add the wildcard mask, and after that you have to inform the router about the destination. So destination, to create telnet sessions on router 0, there are three IPs which are there, right? We have 192.168.1.1, we have 2.1, and similarly 4.1. So we'll add all three IPs into this access list. So we'll go like host 192.168.1.1. After that, you have to tell it that this is for telnet by entering the port number. So either you can type 23 or you can simply write telnet. Both of the ways will work fine. So let's add the port number by writing equals to 23. Press enter. Then we will run the same command again for IP 2.1. Press enter. You are done with the creation of access list. So you have successfully informed the router that these are the IP, I mean 1.0 is the network which can like create telnet sessions on IP 1.1, 2.1 and 4.1. Now, since ACL follows implicit deny, you have to tell the router that other networks of other protocols can be accepted. So we will run the command access list 10 permit ICMP. So ICMP is the protocol used for data transmission, or you can say for making the connections possible between devices. So ICMP source can be any, which means any device, and then for destination as well, you will type any. Press enter, take an exit. Or now you are done with the creation of ACL, and you can have a look at this by running the command show access list, and you will get the details about the access list which you have created. Now we have to apply the same on the interfaces which are there. So we'll go to interface FA00 and we'll say that IP access group 110. I hope you guys are clear why we are using in and not out, right? So since the data will enter inside the FA00, so we are using in. And similarly for interface FA01, we will say IP access group 110 in. Then for Ethernet 1/0, the same command will go IP access group 110 in. Okay. Now we are done with the creation of ACL, and we have also successfully applied it on the available interfaces. Now let's see if these devices are able to create telnet sessions or not. We'll go to PC3, go to command prompt, write telnet 192.168.1.1, which is trying, and after some time it will show you that it got filled. Then we can see that connection timed out since host is not responding. That's because of ACL. Now, even if you try creating sessions for 192.168 2.1 or let's say 4.1, that too will get failed because we have created them for all available IPs. Make sense? And you can also try from a PC of network 3.0 and telnet 192.168.1.1. It says trying, and after some time it will show you as connection timed out. However, if we try creating telnet session from PC0, which is from 1.0 network, it will go successful. 192.168.1.1. We can see it asks us for the login password, and after entering the password, you can like configure the router remotely. Make sense? I hope this is clear to you all now, and let me know if you have any doubt in this. Sure, Sam, I can write that for you. But before that, I want you guys to answer that if you have any doubt or not, or is it clear now? Great. So that's how extended ACL works. And I'm writing the commands for your reference, and you guys can take your time to try this out. So first of all, I hope you will be able to assign IP address and create DHCP pool on all of them. After that, configure telnet on router 0. For that, you need to go to configuration mode, set enable password. Let's take Cisco. Then after that, run the command line vty 0 space 4 and then password. And you have to type login. Take an exit or so these are to be used for telnet configuration on router 0. And after that, you have to go to configuration mode, type access list 110 permit TCP from 192.168.1.0, add the wildcard bits, and okay, ACL is set for 1.1 as well. Yes, Jaspar, we have successfully configured it on all of the interfaces. So add the wildcard bits, and after that, inform the router about destination. So destination can be 192.168.1.1 and equals 23 for telnet. Now for the other destinations which are there, two dot one equals to 23, and similarly for 4.1. Then once these are created, you have to also allow the ICMP protocol, for which you can run the command access list 110 permit ICMP any. Take an exit and go to interface FA0/0, say IP access group 110 in. Then similarly on interface FA0/1, you will run the same command IP access group 110 in, and on interface Ethernet 1/0 as well. You have to perform the same command. These are the commands for the configuration. So this is for the telnet and this is for the ACL. Try this out, take your time, and let me know once you are done with the practical. So we have a doubt here that why PC0 is able to create the telnet sessions. So PC0 and PC1 will be able to create telnet sessions because we have allowed them, since we have allowed the devices of network 1.0. Even if you try adding some device, let's say PC6, and connect it with the switch, assign it an IP address, so if we connect a new PC and okay, I'm not sure why DHCP is not working right now. Okay, maybe because of creation of ACL. So let's assume that even if there was another PC with, let's say, the IP 1.4, if we try creating telnet from that too would have worked. So since we have allowed the devices of 1.0 network, so all the devices which will be connected under network ID 192.168.1.0 will be able to create telnet sessions. Yes, Santosh, you can like create ACL on router number one, and in that case, what will happen is that this router will be connected to some ISP router, right? And will be configured with some IP addresses. So you can simply block these devices to be able to communicate on that network using a standard ACL as well. So take your time, guys. Let me know once you are done with the practical. So the first any here, the first any is for the source, which means any device from any device, right? And the second any is for the destination. So this represents to any device, from any device to any device, and this equals to 23 is for telnet. Telnet is the 23 is the port number of telnet, and we are like specifying the protocol which we are creating this ACL for. I hope everyone is done with the practical. Let me know if there is someone still on it. Otherwise, we are good to go. I'm putting a screenshot of this topology with the commands so that if someone is still on it, they can refer to this. And great. So before we move ahead, I have something to share with you guys. Tomorrow, which is 15th of October, there will be no sessions for CCNA training. And the reason behind that is the festival of the Shera, which we celebrate in India. And because of the same reason, we will not be conducting the class for CCNA. But after that, after this week, in the next week, on Monday and Tuesday, we will have a class. Then on Wednesday, there will be a session conducted for you guys, which will be basically focused on how you can effectively appear for interviews and create your resumes, and what all profiles should be looked by you. So all of that, all of the details related to applying for a job and appearing for an interview, and all other things which you need to know before getting into the industry will be discussed in this session. So I request you all to please attend this, as this will be very helpful to you guys. And before that, on Monday and Tuesday, we will cover our remaining topics. So let's now get back to our topic assigned for today, which is NAT, network address translation. Yes, exactly, Jaswal. We created as if we look at our objective of the lab, it was that only devices from network 192.168.1.0 should be able to configure router 0 remotely, which means that only devices of 1.0 should be able to create telnet sessions. So for the same reason, we created all this configuration, and we denied 2.0 and 3.0 for telnet, for like creating telnet sessions of router 0. Now let's understand how NAT works. So we are going to discuss about NAT. NAT stands for Network Address Translation. So basically, when we look at our categories of IP address, we have two types of IPs. We have the first one we have is a private range, the private IP addresses, and we have second, the public IP addresses. So we need a public IP address in order to like connect with devices over the internet. And basically, if we talk about the IP ranges, IP classes which are there, which is A class, B, and C. In class A, you get 2 raised to the power 24 hosts, which is somewhere around 16 millions. And then in the class B, you have 65,536 hosts available. Then for class C, it is only 2 raised to the power 8, which is 256 IP addresses. These are the only available IP classes, and these are assigned by INA. So IPs are basically assigned by INA, and INA stands for um, assigned number Internet assigned number authority, or let me just quickly have a look at it. Also, I will show you the registries which are there for specific regions. Okay. So this is this is our INA. Okay. Which is Internet Assigned Numbers Authority. And if you look at the IP addresses and AS numbers, so there are some specific registries which are there and which have like responsibility for a particular region. So for Africa region, Afrinic is something which will be assigning IP addresses. So basically you can understand this by like INA has allotted lot of IP to Afrinic for Africa region and another lot of IP addresses to APNIC for Asia Pacific region. Then similarly to ARIN for Canada, USA and some Caribbean islands. Then LACNIC for Latin America and some Caribbean islands. Then RIPE NCC for Europe, Middle East and Central Asia. So these are some registries which take care of these particular regions for the IP assignments. Now, when it comes to class A IP addresses, some big companies like Apple, Microsoft, and so on bought some of the IP ranges of class A. And since these purchases were made in the very initial days of internet and subnetting was not very like was not very much into the picture, so there was a huge wastage of IP addresses, and after some period of time the IP were like exhausted. There were no more IP ranges or IP addresses to be able so that the INA can assign to any company or any organization. So in order to avoid that, something known as private IPs were used. So private IP ranges are there which you can use on your local connections, and those IP addresses won't help you in order to like connect to the internet. So there are some ranges for class A and class B and C. So for class A, it is 10.0.0.0/8, which means from 10.0.0.0 to 10.255.255.255. Then for class B, it is 172.16.0.0/12, which is there from 172.16.0.0 to 172.31.255.255. So this is the range of class B for private IP addresses, and for class C it is 192.168.0.0/16. Then the range goes from 192.168.0.0 to 192.168.255.255. Now we will understand how these things work, how these private IP addresses are used to make devices communicate with the internet. So now let's assume that there is one router here, and under this router there is a switch, then some end devices. Now let's assume that 1.0 is configured on this network, and this device is 1.2, 1.3, 1.4. Then this router gets a connection from let's say ISP, and this ISP helps this router to connect to the WAN networks which are there. So you can consider it as the internet. Now there will be someone with another router running the same IP range probably. So let's say, let's for our basic understanding, let's take 2.0 here, and there will be a end device with 2.2, 2.3, 2.4. So it's basically 192.168 1.0, and similarly 192.168 2.0. Now if we configure routing, if we talk about our packet tracer labs, if we configure routing between these two routers, these devices will be able to communicate, right? Since they are in different networks, after the configuration of routing, they'll be able to communicate. But imagine this network also being configured under network 1.0. So let's say this router was also configured with a network of 192.168 1.0, and there were some end devices again with the same IP addresses 1.2, 1.3, 1.4, or maybe one more end device 1.5. So if they try to communicate with each other, let's say this is PC A and this is PC B. So if they try to communicate, if PC A tries to communicate with PC B, can I say there will be an IP conflict? Yes, right. Since the IP addresses of both the devices are same, there will be a conflict of IP. In order to avoid the exhausting IP addresses, NAT was used. So NAT basically is network address translation. So what it does is this private IP address is translated to a public IP address. So let's say we had a IP from ISP. Let's take an example. Just for an example, we are taking let's take 214.10.5.7. So this was the IP address which was assigned to us by the service provider, by the internet service provider. And now what NAT do is this IP address 1.2 will be translated to this particular public IP address, and that will be used in order to make communication with the internet. Make sense? Do you understand how NAT works? Great. So you people are now clear how translation works. Okay, so Neeraj, what's happening here is we are just converting our private IP address. So as we just discussed, there are some private ranges for class A, B, and C, which is 10.0.0.0/8 and 172.16.0.0/12 and 192.168.0.0/16. So these are the ranges which we can use privately without even paying for these IP addresses. But in order to connect with devices out there in the internet, you have to like connect with a public IP address. So what's happening here is ISP buys one IP. Let's assume that ISP gets one IP from INA. So INA assigns a public IP address to this ISP, and this ISP assigns from that range an IP to you on this router. And what's happening here is all these devices are getting converted to that public IP address in order to reach out to the internet. And for this purchase of IP address, you pay the ISP your monthly rental for your internet. I hope that it makes sense to you now. So basically, INA is assigning IP to ISP, for which ISP pay to INA, right? And similarly, that ISP is providing you some IP address which you can use in order to reach to the internet. And for that particular IP address, you pay your monthly rental to your internet service provider. Now, if we talk about address translations, there are some ways which we can use. So the very first way which can be used is static net. Static net is a, like, you can understand this, that a router creates a table, and every private IP, so let's say 192.168.1.1, will be assigned a public IP address. Similarly, 1.2 will be assigned another public IP address. So you have to configure them all statically. So that's how static network, and you can say that it is one-to-one mapping, right? We are assigning one private IP, one public IP, right? We are assigning one public IP to one private IP. So we can understand this by one-to-one mapping. Then the second category we have is dynamic NAT. So this is not something we use in our networks when we talk about today. So this is not something we use because it takes a lot of configurations, and a huge number of public IP would be required, right? Then we have dynamic NAT, where we create a pool, just like DHCP. You just create a pool for the private IP addresses, and they get the public IP randomly. So the public IP which will be assigned to this 192.168.1.1 PC will be assigned through a pool which you will configure on the router. So the difference basically here and in static NAT and dynamic NAT is, here you assign it manually by yourself, and here it's happening automatically by the router. So it just quickly assigns the IP from the pool to this private IP so that it can reach out to the internet. Then after this, we have the third way which we usually use, which is PAT. So the first one was static NAT, then we had dynamic NAT. Now we have PAT. PAT stands for port address translation. And we also call it NAT overload. Now it can convert around, I would say, more than 65,000 private IP to one public IP. Isn't it cool? When we were just assigning one public IP to one private IP, this PAT is assigning one public to 65,000 private IPs. Now we will understand how this works, and what basically is done here, that 65,000 private IPs are able to communicate using one public IP. So you all must have maybe observed something after an IP address like this, let's say 8055 or .1092, anything, any number. So this is basically the port number, which is usually there after the 32 bits IP address. So we use these port numbers to make use one public IP. So we'll be using one public IP, and we'll use the same public IP with a different port number for a different private IP. Make sense? So let's say we have the first private IP here, and then we have a second private IP here. So we are assigning the same IP address with different port numbers to these private IPs so that they can communicate over the internet. You guys understand how PAT works? Is it clear to you guys, or do you still have any doubt in this? I can repeat myself. Okay, so basically the conversion here happening is using some port numbers. So what's basically PAT do is, so let's assume you have a router here and some end devices connected with 1.2, 1.3. So this 1.2, let's say the public IP is 210.115.1.7. Okay, so this 1.2 will use the same IP address, which is 210.15.1.7 with the port number 1. And now this 1.3 will again use the same IP, the same public IP with a different port number, let's say 2. I mean, these 1 and 2 is not the appropriate values, but that's just for our basic understanding. So they will use some different port numbers with different public IPs in order to reach out to the this network, which we call internet. Make sense? Do you understand how conversion work here? Please let me know, Mohammed, if it's still not clear to you. I'll repeat. And we have a question that how many ports are available. So there are more than 65,000 port numbers available. I guess 65,500 something. So you can use them all in order to reach out to the internet. Okay, so now we will do a practical for PAT uh, and we'll understand how translation works. So we are going to add some routers and let me just, okay, add a switch and a couple of end devices. Let's take 4 end devices here. So let's understand this with the example of your home internet connection. So assume that this router is your router, which is like placed in your home, and this is the gateway. Now this is the connection which you are getting from the ISP, and these routers are nothing but, you can consider them as internet, right? So we will configure 168.10.0 on this network. Then we can configure 15.0.0.0 here, and let's take 24.0.0.0 between these two routers and 37.0.0.0 between these two. Okay, so now we'll go to router number 1 and say no. Enable conf-t go to interface FA0/0, assign it the IP address 192.168.1.1. Shut down. On interface FA0/1, we will assign IP address 15.0.0.1 and no shutdown. Now let's create a DHCP pool as well. We'll see if PCs are getting IP addresses. Okay, now we will configure the IP address on these routers as well. So say no, enable conft interface fa 0/0, then IP address will be 15.0.2 and interface fa 0/1, IP address 24.0.0.1 and subnet mask no shutdown. 00 IP will be 24.0.0.2. FA01 will be assigned the IP address 37.0.0.1. Key interface FA0/0 IP address 37.0.0.2. Here we go. We have successfully configured IP address on all of the devices. Now we will configure EIGRP on these devices and let's see if they are able to communicate with each other or not. So also what we are going to do here is we will create EIGRP here as well on router number 1, which is our local router, but we will only advertise 15.0.0.0 network, not the 192.168.10.0, and we will try translating this 192.168.10.0 to this 15.0.0.0.0 so that it can reach out to this part which we have assumed as internet using that IP, the public IP. So now let's quickly go to router number 3 and configure EIGRP. Take an exit. So the router EIGRP, let's take 10, the network dot 0.0.0. Then we have four dot zero dot zero dot zero. Take an exit. Then router 4 will go like router EIGRP 10 network 24.0.0.0, and here we can see the agency coming up. Then the third network is 37, right? You can exit. Similarly, go to router number 5 and the router EIGRP10, network 37.0.0.0. We can see that neighborship is coming up. Now on router number 2, as we decided, we are going to just advertise 15.0.0. So router EIGRP10 and network 15.0.0.0, right? Now, if we try making communication between PC7 and router 5, tell me if it would be possible or not. If I try pinging this PC7 from the router 5 from PC7, would it be possible? You can use any routing protocol, that's for just our basic understanding. No, right? Let's try. It says it in progress, then it says failed. Okay, we have some yes as well. So we will understand. Now, if we have a look at our router and if we see the routing table, we can see that we have 37.0.0 in our routing table, but still we are seeing that the communication is getting failed. May I know why? Absolutely. So basically what's happening here is this router know about 37.0.0. This PC will check its local routing table, and when it see that 37.0.0 is not in its routing table, he will send it to the gateway, which is router number 2. Now this gateway will transfer the data towards the next hop, which is router number 3. Now when router 3 looks into its routing table, you will realize that okay, this data is coming from an unknown source, right? Because router 3 is not aware about this network. So for the same reason, they will not like transfer the data ahead and will drop the same right there. So since a packet would be able to travel out of the gateway, but the router won't receive any reply for that. So the communication is getting failed for the same reason. But now we are going to configure NAT on this router, and after that we will try making communication over the internet, and let's see if that works or not. So in order to do that, you have to first create a list, which will be using access list only. So we will be creating a standard access list. So the command will be access list to 168 10.0 and the wildcard bits. So we have created a access list for the IP network. Now we will perform network address translation. So the command will go like IPNAT, and after that inside. So basically private network can be considered as inside and public can be considered as outside. So we are doing this translation of private IP addresses, right? So we'll be using inside. We are doing this for 192.168.10.0 for this part, right? So we'll use IPNAT inside, and after that you have to tell it that this is the list which is the, so you have to add the source list 10 for this network. So basically we are referring to this network using this list 10 which we have created just now, access list 10. So we wrote source list 10. After this, if you press question mark, it will ask about the interface. So it's asking you that where do you want this translation to happen? So we say interface FA0/1. So we want that this IP, which is 192.168.10.0, should be translated here, so that whenever it takes an exit, it gets translated to a public IP address. So we inform the router about the interface, and then after this, if you press the question mark again, is that you have the option over